Hello everyone, welcome back to another STEM Helps video. We'll be continuing on our Miss Charitat's midterm review, except we will be having a bit of a long video here. We'll be doing numbers 31 all the way through 50 odd, and I'll be doing 31 through 35, the entire thing. Alright, so number 1, does the graph represent a function? So you can test this by using the vertical line test, and the vertical line test says that if you draw a line through every single point, let's say for here, like for example, then is there any point in the function where when you draw a vertical line, is there 2 points that hits the line? And so the answer is no. That means, does the graph represent a function? Yes. Give the domain and range of a function. So the domain is, let's write D and R. So the domain is going to be the restrictions on the x-axis. And assuming this is a parabola, right? It's going on forever. Assuming this is a parabola, this will go on forever to the left and forever to the right. So that means there are no restrictions. So this means that it's not including negative infinity to positive infinity. And the range, well, it looks like it's going down forever, but is it going up forever is the big question. It looks like it's stopping at around this point, and I can draw a line, and it looks, I would say it's around 2.5 actually. It's pretty much a wild guess at this point, but if you get around that value, then I'm sure you'll get the point. On which interval is the function increasing? So the function is increasing when it looks like it's going up. It's going up, like, increasing is like, if you try and walk on this, it'd be really hard. So like up until right about here, it'd be really fine. But from here on out, it would be really hard to walk on if this is a hill. See, if this was a hill, it would be super hard to walk on. So from negative infinity, right, assuming that it keeps going down, all the way to around what's the x-axis. And so we usually talk in terms of x-axis. 1, 2, 3, 3.5. So we're assuming that this x-axis, sorry, the x value of this point is 3.5. And box. On which interval is the function decreasing? So that means it's going down, or if you're walking on it, it would be super easy. Almost too easy, you might fall flat on your face. So the interval is decreasing from 3.5 to infinity. Name the relative maximum of the function. So it's saying what is the, so it's saying what is the relative maximum. So you need to report the y value. If it says where, even though it's not, I'm just saying in general, if it's asking where, that means it's asking for the x value. So in this case, it's asking for what the y value is, name the relative maximum of the function. I'll write it in terms of coordinate notation, so 3.5 comma 2.5. And so what is the maximum value? Maximum value is 2.5. Alright, that was a pretty simple one. Number 37 is also a simple one. If you want, I'll give you a couple of seconds to try it on your own. Okay, so given the domain and range, if you're having trouble with domain and range, here, let me explain it to you. I'm gonna first give you my answer to it, and then I'll explain why I got those answers. So the domain, I think the lowest x value is 1, so 1 inclusive, and it ends at 4. That's the maximum x value. The range, the lowest y value, okay, is 1, and the highest y value is 3. So how I like to think of it is, if you were to draw a line and x equals 1 all the way down, and x equals 4 all the way down, y equals 3, hopefully using a straight edge or a ruler, and y equals 1, the points, if they're granted always in brackets, then that means that the points or the function is inside this box or on the lines or vertices of this box. So when you say the domain and range, you are basically making a box for where the function is. So again, domain is equal to x and range is y. Number 39. I'll give you a couple seconds to work on it. Okay, I'm just going to rewrite this function. So d of x times c of x. And so d of x is equal to 3x squared minus 2x plus 7. So put this all in parentheses. And now you're multiplying it by c of x, which is 10x minus 3. And we're trying to find what this equals. So what you're supposed to use now is our little friend of ours, FOIL. So first, outer, inner, and last. Alright, so I multiplied this term by this term. So I multiply the coefficients first. 3 times 3 times 10 is 30. X squared times x is x cubed. So what I basically did was, when you multiply x's, you add their exponents. So this is 3. So 3x squared times negative 3 is going to be negative 9. And then now drop the x squared. Negative 2 times 10 is negative 20. X times x is x squared. Negative 2 times negative 3 is positive 6. Drop the x. 7 times 10 is going to be equal to 7 times 10 is equal to 70. Positive 70. X. And finally, 7 times negative 3 is negative 21. Alright, let me simplify this. So we're trying to find the highest exponent, and it looks like it's x cubed. There are no more x cubed terms, so we just write 30 x cubed. And so now the next term is going to be, alright, looks like it's x squared. So what you do now is you pair up all the x squareds and add the coefficients. So negative 9 plus negative 20 is going to be equal to negative 29 x squared. Alright, the next one is going to be x. 6 plus 70, you add the coefficients together, plus 70 x, and finally minus 21. And that's our answer. Alright, cool. Our next problem, find the slope of PQ if P equals 1, 1 and Q equals 5, 4. So the formula for a slope, so slope formula, if you remember, is equal to y2 minus y1 over x2 minus x1. And you can pick whatever y2 and x2 are and y2 and y1 are. In this instance, I'm going to pick q as our y2 and x2. Alright, so what is the y value of q? 4. Just keep going. What's the p value of, what's the y value of p? 1. What's the x value of q? 5. What's the x value of p? 1. We can simplify this using, these are technically parentheses, so we can use order of operations. So 4 minus 1 is 3, divided by 5 minus 1 is 4, and that is our slope. This one's a bit of a tricky one. I'll let you have a couple of minutes to try and solve it for your own. Okay, so what is the equation of a line through a point -4 comma 2 and have a slope of 1. So we can write the normal standard form y minus y1 equals m, which is the slope, x minus x1. Alright, and so now we just have to plug in these values. We have the slope and each point. So we can say y minus, and so now we know that it is equal to 2 is equal to 1 x minus -4. Alright, and this slope of 1 doesn't change anything. I'm going to keep this left-hand side exactly the same. So y minus 2 is equal to, distribute the 1, doesn't do anything. X, negative times negative is positive, plus 4. And now we subtract, add 2 to both sides. So y equals x plus 4 plus 2 is equal to x plus 6. So y is equal to x plus 6, and A is going to be our answer. Alright, cool. Next problem. Spencer is launching potatoes with a homemade potato gun. The graph below displays how far the potato goes depending on the angle Spencer launches the potato. If Spencer launches the potato at 60 degrees, how far will it go? And it looks to be about, I'm going to say 9 meters. So what you do is you look at 60 and see where around the range it is. And so you use your units of range. What angle should Spencer use if he wants the potato to go as far as possible? So now you are looking for maximum value. Okay? And so you're trying to find where on the graph is the maximum value, and it looks like around here. And so you need to try and find what the x-axis is. The x-axis looks to be around 45, so 45 degrees is going to be our answer, because it is the maximum range. Alright, next question. Given the point 84, what's the equation of the horizontal line? What's the equation of the vertical line? So if we draw a normal coordinate system here, it doesn't matter if we draw a horizontal line, right, going along like this, it doesn't matter what the x-axis is. We are only looking at y, so this will give us an answer in terms of y. So we need to try and find the y value here. And if we draw a vertical line, it doesn't matter what the y value is, we're trying to find x. So the x in this point is equal to 8. And finally, the y value is equal to 4. Alright, this one's a bit of a tricky one. I'll give you a couple of seconds to solve it. So first thing we're going to do is we're going to add 4 to both sides. So we're going to say y is equal to 1/2, keep the parentheses, x plus 3 plus 4. And now what we're going to do is we're going to simplify this entire thing. 1/2 x plus, let me change the color, 3/2 plus 4. And the reason why I wrote this is because these are like terms. And so what we know about like terms is now we're supposed to make them add up to each other. 1/2 x plus, this is a whole number and this is a fraction. So let me show you what you're supposed to do. You're supposed to multiply this by 2 divided by 2. And so what this becomes is 8 divided by 2. You multiply the numerator, this is by 1, multiply the numerator, multiply the denominator, and this is equal to 4. So now what we can do is the denominator is the same, so we don't violate any laws with adding fractions, and so we can very easily add this. It is 11, let me change colors. It is going to be 11 divided by 2. So now this is very easy to graph. So it says when x equals 0, y equals 11 over 2. So if x equals 0, 1, 2, 3, 4, 5, around 5.5. And so the slope can tell us another thing, and that's all we need. The slope tells us that, so the numerator is rise, so we go up one whole step, and then run 2 spaces. So it's right around here. And now we can do the exact opposite and keep going. Hopefully I'm doing this correctly. And so you would be able to draw a straight line that looks something like this. And if there's any questions, please comment down below, and I hope that's helpful.